The world we see from above is a breathtaking tapestry of blues and greens, a delicate and interconnected system. For decades, we have taken to the skies, crossing vast oceans and continents in a matter of hours. This ability to travel has connected us in remarkable ways, allowing us to share cultures, ideas, and experiences across the globe. Yet, this incredible feat of engineering has come at a cost to the very planet we so admire from our windows. The skies, so clear and vast, are feeling the strain of our journeys. The traditional fuels that power our aircraft release substances that warm our world and change our climate. We stand at a pivotal moment in our history, a time when our ingenuity must be directed towards preserving the natural world. The familiar roar of a jet engine is a sound of progress, but it is also a reminder of the delicate balance we are disrupting. The challenge before us is immense, but it is one we must face with determination and hope. We must find new ways to fly, ways that do not harm the fragile atmosphere that sustains all life on Earth. The search for cleaner, more sustainable aviation is not just an engineering problem. It is a promise we make to future generations who will inherit this magnificent planet. Our quest for a solution has led us to explore remarkable new technologies. Scientists and engineers around the world are looking to nature's simplest and most abundant element for an answer. This element holds the potential to revolutionize air travel, transforming it from a source of pollution into a beacon of sustainable innovation. It offers a vision of the future where we can continue to explore our world without leaving a harmful footprint behind us. The journey towards this future is just beginning, but it is a journey filled with incredible promise for the health of our planet and all its inhabitants. Imagine a world where aircraft glide through the atmosphere, leaving behind only a trail of pure water vapor. This is not a distant dream, but a tangible possibility that is drawing closer with each passing day. The transition to a new form of power for our planes represents one of the greatest environmental challenges of our time. It requires us to rethink everything we know about flight, from the design of the aircraft to the infrastructure that supports it. But the reward for this effort is a cleaner, quieter, and healthier world for all living things. So, what is this remarkable element that holds such promise? It is hydrogen, the most common substance in the entire universe. It is all around us, a fundamental building block of water, of stars, and even of life itself. In its pure form, hydrogen is a gas that is incredibly light and packed with energy. For over a century, we have understood its potential as a powerful fuel source. When hydrogen combines with oxygen, it releases a tremendous amount of energy, and the only thing it creates in the process is simple, clean water. This remarkable property makes it an ideal candidate to power our world. Using hydrogen as a fuel is a wonderfully elegant process. Unlike fossil fuels, such as the kerosene used in today's jets, hydrogen contains no carbon atoms. This is incredibly important. When we burn fuels containing carbon, they release carbon dioxide, a greenhouse gas that traps heat in our atmosphere and drives climate change. By using hydrogen, we can completely eliminate these carbon emissions from flight. The energy is released through a chemical reaction, not by burning in the traditional sense, which gives us power without the pollution that has for so long been an unavoidable consequence of travel. There are two primary ways we can harness the power of hydrogen. The first is to burn it directly in a specially designed jet engine, much like we burn jet fuel today. This method provides the immense thrust needed to lift a large aircraft into the sky. The second, more advanced method is to use a device called a fuel cell. A fuel cell is like a continuous battery. It combines hydrogen with oxygen from the air in a controlled chemical reaction, producing electricity to power electric motors. This process is not only clean, but also remarkably quiet and efficient. The production of hydrogen is also key to its environmental credentials. To be truly green, the hydrogen must be created using renewable energy. One of the cleanest methods is called electrolysis, which uses electricity from sources like wind or solar power to split water molecules into hydrogen and oxygen. By using the power of the sun and the wind, we can create a completely sustainable fuel cycle. We take water from the earth, use clean energy to turn it into hydrogen fuel, and when the fuel is used, it returns to the atmosphere as water. It is a perfect closed loop. Creating an aircraft that runs on hydrogen presents new and exciting challenges for engineers. Hydrogen, despite being very light, takes up a lot of space, even when it is stored as a liquid. To keep it liquid, It must be cooled to an incredibly low temperature, around -253 degrees Celsius. This means that the fuel tanks on a hydrogen-powered plane must be very different from those we use today. They need to be exceptionally well insulated, almost like a giant thermos flask, and they will likely be larger and perhaps shaped differently, which will change the overall look of the aircraft. The aircraft itself will need to be redesigned to accommodate these new fuel systems. We may see planes with longer fuselages to house the cylindrical tanks, or perhaps even blended wing bodies where the tanks are integrated into the structure of the wings. These new designs are not just for storage, they are also an opportunity to make aircraft more aerodynamic and efficient than ever before. Engineers are exploring innovative shapes that reduce drag and improve performance, making every drop of hydrogen fuel count. It is a complete reimagining of what an aeroplane can be. Inside the aircraft, the power systems will be fundamentally different. If the plane uses hydrogen combustion, the engines will be modified gas turbines, optimized to burn hydrogen safely and efficiently. If it uses fuel cells, the aircraft will be propelled by quiet electric motors. These electric systems could allow for new possibilities, such as placing multiple smaller motors across the wings to improve lift and control. The experience for passengers would also change, with a significantly quieter cabin and the knowledge that their journey is having a minimal impact on the environment below. The journey to making hydrogen flight a reality is a marathon, not a sprint. The first hydrogen-powered commercial aircraft are likely to be smaller, regional planes that fly shorter distances. These will serve as crucial stepping stones, allowing us to test and refine the technology in the real world. As our expertise grows and the technology matures, we will see larger, long-haul aircraft take to the skies. It is a gradual but determined process, one that moves us step by step towards a future of truly sustainable global aviation. The most profound benefit of switching to hydrogen-powered flight is the protection it offers our planet's fragile climate. Aviation is currently responsible for a significant portion of global carbon dioxide emissions, and as more people travel by air, this share is expected to grow. By eliminating carbon dioxide from aircraft exhaust, hydrogen planes can help us put a brake on global warming. This single change has the power to drastically reduce the aviation industry's impact on the climate crisis, ensuring that our skies remain a stable and healthy part of the Earth's system for millennia to come. Beyond the invisible threat of greenhouse gases, hydrogen also helps us tackle another form of pollution: poor air quality. Conventional jet engines release not just carbon dioxide, but also other harmful pollutants like nitrogen oxides and soot particles. These substances can contribute to respiratory problems and harm ecosystems near airports. Hydrogen combustion produces only water and some nitrogen oxides, which can be minimized with advanced engine design. And if fuel cells are used, these pollutants are eliminated entirely. This means cleaner, healthier air for communities living near airports and all along the flight paths. Another, often overlooked benefit is the reduction of contrails. Those white lines we see trailing behind jets are not just water vapor. They are ice crystals that form around soot particles in the exhaust. These man-made clouds can trap heat in the atmosphere, contributing to warming, especially at night. Because hydrogen planes produce no soot, the contrails they form would be different and likely have a much smaller warming effect, if any at all. This is another subtle but important way in which this new technology can help restore the natural balance of our atmosphere. Ultimately, the transition to hydrogen aviation is a powerful statement of our commitment to the planet. It is a choice to innovate for the sake of nature, to harness our intelligence not just for our own convenience, but for the well-being of all life. By embracing this technology, we can continue to connect our world and explore its wonders, but in a way that respects and preserves its delicate beauty. The sight of a hydrogen plane soaring through the sky, leaving only water in its wake, will be a symbol of hope, a testament to our ability to find a better way forward, ensuring a greener, healthier horizon for all.